In this video, I'll be discussing the electromagnetic theories that govern this wireless Bluetooth speaker. Your phone uses Bluetooth to send roughly 1 million ones and zeros every second when you listen to music on your wireless speaker. What is Bluetooth? Information can be transmitted using the electromagnetic field known as Bluetooth, which changes over time. It consists of an electric and a magnetic component that are perpendicular to one another. The right-hand rule, which states that the middle finger points in the direction where B is polarized, and the index finger points in the direction where E is polarized. And the direction of the wave propagation will then be where your thumb is pointing. Yet how? Similar to how we observe that visible red light with a wavelength of 700 nanometers and green light with a wavelength of 540 nanometers can be seen. Bluetooth uses a wavelength of 121 millimeters to transmit a binary 1 and 124 millimeters to transmit a binary 0. The information about the audio signal is contained in these ones and zeros. These wavelengths correspond to frequencies of 2.47 GHz and 2.42 GHz respectively, according to the formula V equals F lambda, which indicates that Bluetooth uses radio waves. Now let's discuss about the voice coil, so you can understand how speakers make sound. The magnetic field strength expression of the voice coil, which may be seen as a finite length solenoid, is displayed on the screen. It is essential to recognize that current affects the magnetic field's strength in this situation. We can also verify the magnetic field's direction using the right-hand grip rule. This implies that adding additional current will strengthen the magnetic field, reduced by lowering the current, and its poles can be changed by switching the current's direction. The voice coil is surrounded by a permanent magnet, and the voice coil rests in that space. The magnetic fields of the voice coil and the permanent magnet interact when a current is applied through the coil, creating a Lorentz force. The force acting on the currently selected element is displayed on the screen, and the right-hand rule can be used to identify the force's direction. The index finger points in the direction of the current that is entering the page. When we look at the upper half of the magnet, you can see that the force is working to the right. When you look at the middle finger, which is pointing upwards in the direction of the magnetic field, your thumb is pointed to the right as well, if you apply the right-hand rule to the bottom part. After that, the cone and the voice coil are both moved to the right. You will also see that the voice coil is pulled to the left and back into the gap if you reverse the direction of the current. The voice coil receives a time-variant current that imitates the original audio signal. This results in a complex magnetic field surrounding the coil and a particular interaction with the magnetic field of the permanent magnet. This causes the voice coil to resist and retract at the same frequency as the original signal. Air molecules collide as a result, creating high and low pressure areas that our ears detect and our brain interprets as sound. And that's how a wireless Bluetooth speaker works.